All right, page 4. Solve the system. 2/3 x plus 1/2 y equals 4, and negative 1/6 x plus 1/8 y equals -3. So I'm going to fraction buster these a little bit first. Not a little bit, but... So I'm going to multiply the first equation. The common denominator for 3 and 2 is 6. And so that's 6 times 2/3. 3 goes into 6 twice. 2 times 2 is 4x. And 6 times 1/2 plus 3y equals 6 times 4, 24. The second is 6 and 8 have a common multiple of 24. So I need to multiply this equation by 24. So I get negative 1/6 times 24. 6 goes into 24 4 times. So that's negative 4x. And 1/8 times 24 is 3 plus 3y. And 24 times -3 is -72. And so when I add these two equations together, we get negative 4x plus 3y equals -72. I get 6y equals, that's 48, negative 48, divide by 6, so y equals -8. And then we plug that in, negative 4x plus 3 times -8 equals -72. Negative 4x minus 24 equals -72. Add 24. And negative 4x equals -48. Divide by -4, and x equals positive 12. So 12, -8 is my solution. Number 40. We're going to subtract the 6x and add the 8, so we get x squared minus 6x plus 8 equals 0. I know it says solve by graphing, but if we can factor it, and this is a multiple choice test, so we should try, we can graph it and factor it and solve it all at the same time. So what two numbers multiply to 8 and add to -6? That's -4 and -2. So x is equal to 4 and 2. Therefore, on my graph, I'm going to have two x-intercepts at 4 and 2, and my vertex is halfway between, so x would equal 3 for my vertex. And that would be 3 squared minus 6 times 3 plus 8, which is 9 minus 18 plus 8, -9 plus 8, which is -1. So my vertex would be at 3, -1. There's my graph. And again, still my answers are 4 and 2. Number 41. Find the value of the discriminant. Let's remember that the discriminant is b squared minus 4ac. So when it wants the value of the discriminant, we have to plug it in. So b is -12 squared minus 4 times 9 times 4. -12 squared is 144 minus 9 times 16. That's 54, 144 as well. And so the value of my discriminant is 0, and then describe the number and types of roots. When my discriminant is 0, this is one real rational root. 42. Determine whether it has a maximum or minimum and find that value. So we have positive 5x squared minus 20x plus 3. When this is positive, that means the parabola opens up. So that means we have a minimum. To find it, we find our vertex, negative b divided by 2 times a. So negative 20 over 2 times 5. So that's positive 20 over 10, x equals 2. That's not the maximum. That's the x value that gives me the maximum. So I plug that in. 5 times 2 squared minus 20 times 2 plus 3. And that's 5 times 4. That's 20 minus 40 plus 3, which is negative 20 plus 3, negative 17 is the minimum. So we have a minimum of negative 17. And let's see, the last one is 3x, number 43, the last one on this page is 3x squared minus x minus 4 equals 0. I moved that to the other side, so it's all on one side. Use my guess and check strategies. I have 3x and x. That's the only way to get 3 is 3 times 1. So I have the options of 2 times 2 or 4 times 1. I like to start with 2 times 2 and see what that gives me. I get 6x and I get 2x. And in no way is that going to give me 4x, so that's not the right one. And if I put the 4 here, I'm going to multiply by the 3. That gives me 12. That's not going to work either. So let's try putting the 4 with the 3 and the 1 with the x, and that gives me 3x and 4x. And that gives me, let's see, sign-wise, it needs to be negative 4 and positive 3. So I have 3x minus 4, and I have x plus 1. And it says to solve, not just to factor. So I have to take 3x minus 4 equal to 0, x equals 4 thirds, and x plus 1 equals 0, x equals negative 1. Those are my two answers. Okay, so here's a weird one. It says at the top, solve each equation by completing the square, and then it says use quadratic formula. We're going to ignore this because we don't want to complete the square on this anyways. It's 2x squared minus 9x plus 5. If I have to complete the square, I have to divide this by 2, and then I get 9 halves in the middle, and that's an ugly completing the square problem. So we're going to use quadratic formula, negative b, so negative negative 9 plus or minus square root of b squared, negative 9 squared, minus 4 times a, which is 2, times c, which is 5, all divided by 2 times 2, which is my a. Now that's positive 9 plus or minus the square root of 81 minus 8 times 5, which is 40, divided by 4. 9 plus or minus the square root of 41 over 4. 41 is a prime number, so that can't be simplified anymore. Number 45, simplify. 4c squared minus 12c plus 7 minus c squared. You have to subtract the 2c as well, and you have to subtract the negative 5, so you end up adding. Don't forget, when you're subtracting the parentheses, it's everything that gets that negative and that's being subtracted. So I get 3c squared minus 14c plus 12. And number 46 wants to know the number of real roots, so let's highlight them here. We have 1, 2, 3, 4. The real roots are where the graph crosses the x-axis, and there are 4 of them. If there was numbers and we asked you to estimate, you would just tell us what they are. And graph the function f of x equals negative 2x plus 2x plus 2. So let's get a better color. We're going to start by finding the vertex. Negative 2 divided by 2 times negative 2. Negative b over 2a is that formula. Negative 2 over negative 4. Negative 2 over negative 4 is positive 1/2. So we're going to make a table. We have positive 1/2 and 0 and negative 1. I'm going to plug in those numbers. I like 0 because I know that the answer is just 2. Negative 1 is negative 2 times negative 1 squared plus 2 times negative 1 plus 2. That's positive 1 times negative 2, which is negative 2 minus 2 plus 2, negative 4 plus 2 is negative 2. And then let's plug in 1/2. Negative 2 times 1/2 squared plus 2 times 1/2 half plus 2. I don't know why I keep moving this thing around. And that is negative 2 times 1/4 plus 1 plus 2. And 2 times 1/4 is 1/2, so that's negative 1/2 plus 1 plus 2, and that is 1/2 plus 2, which is 2.5. So I have at 1, 0, I'm at 2. At negative 1, we're at 2.5. I'm sorry, at negative 1, we're at negative 2. And at 1/2, we're at 2.5. And then we have some symmetry. And there's our parabola. Again, determine if it has a max or a min, then find the max or min. So the x squared is positive, so it's going to have a minimum because it opens up. And we use negative b over 2a. That's negative 2 over 2 times 1. So that's 2 over 2, which is positive 1. And we plug it in, x squared, that's 1 squared, minus 2 times 1 plus 2. So that's 1 minus 2 plus 2 equals 1. So it has a minimum value of 1. Number 49. Sorry, my dog, again, being annoying. Let me just move this stuff out of the way so we have some space. 49. If I have the roots or zeros of negative 5 and 2, it wants me to write an equation where a, b, and c are integers, and we're just going to assume a is 1. So if my root is 5, then my factor is x plus 5, right? Because if I solve that, I would get negative 5. And if my root is 2, my factor is x minus 2, and that's x squared plus 5x minus 2x minus 10. That's using FOIL. So we get x squared plus 3x minus 10 is the equation we would have there. And let's see, number 50, factor x squared plus 3x minus 28. What two numbers multiply to 28 and add to positive 3? X and x, we're looking at 4 and 7. If I want a positive 3, the 4 has to be negative and the 7 has to be positive. And it says to solve, not just to factor, so x equals 4 and negative 7. And the last one for this page, 2x squared plus 3x minus 14. I don't know why it does that. 2x squared plus 3x minus 14 equals 0. So we can only use 2x and x. 14 is 7 times 2 or 14 times 1. I'm going to try 7 times 2. And my outside is 4x, and my inside is 7x. I want it to be positive 3x, so this works for me if it's positive 7 and negative 4. And then 2x plus 7 equals 0. So x is negative 7 halves. And I can divide by 2. Let's show better work here. And x minus 2 equals 0, so x equals 2 and positive 7 halves.